Hi there, this is Jacob Nash Algebra Lessons, and this is Unit 6, Lesson 9, on solving radical equations. So, we only have 2 more lessons in this unit, and then there will be the last unit on conics. But I have done some test reviews on units, but that was only the ones that were super long, and this wasn't a super long unit, so that's not necessarily needed. So I had one for like the polynomials and like rational units and things like that, but I'm not doing that for this one, so sorry about that. So we know that we've solved lots of different equations so far in Algebra 2, like rational ones, but how do you do it if it's under a radical? Well, it makes sense. You just have to kind of eliminate the radical. That's just what you have to do. So you first have to isolate it by making it by itself. So that means you have to divide, add, subtract, multiply, anything to make it just by itself. Then you multiply the sides by the reciprocal of the radical. We'll see what that means. And then you just solve as normal. After that, after you do step 2, you can eliminate the radical, so then it will look a lot simpler. You sometimes have to factor, and the answers are the x-intercepts. So we know what these would look like. So if it was just a square root function, it would look like that. But in some cases, it could even look like that, where it's like sad looking, kind of. And so it has 2. And that's how there can be 2 answers. But as with other things, you have to see if they're extraneous, meaning if you plug it in, it won't work. So let's look at 3 examples. So here's one. So we need to first isolate the radical. So that means this 3 needs to go away. That's what it needs to do. So we need to, how can we make it go away? Well, since there's no plus or minus here, we know that means we have to divide it. So we divide by 3. So we have 5x plus 308. This is kind of a weird problem. But hopefully we'll have a nice answer. So equals 7. So now we need to multiply by the reciprocal. So if we just kind of take this away, oh, that's not good. We know that really we would, I already talked about this in a different lesson, but that really is multiplying by 1/3 to the power of 1/3, sorry. Because since this is 3 and then there's really a 1, so 1/3. So that's what that means. So that means we have to multiply this by the reciprocal. Well, actually both sides, really. Because we know when we multiply by the reciprocal, we get 1. And if we get 1, that means we eliminated the radical. That's why we're doing that. So that means we multiply this by 3/1, or just 3. So now we have eliminated the radical, and we have 5x plus 308 equals 343. Subtract 308 on both sides. You get 5x equals 35, and then divide by 5, x equals 7. So that's our answer. So even though we had weird numbers like 308, that we still got at least a simple answer. Now we need to check. Well, that would mean that this would be our x-intercept, but if it's extraneous, then it wouldn't be. So let's see if it's extraneous. We know that it could, since this is a cube root function, so it could really be, it would be something like this. That we know that's the typical thing, but if it was up here like this, while still it would connect to it at one point, but that doesn't really apply to this. So we can already kind of say that this is not extraneous, but let's plug it in just to see. So 5 times 7, oh, we still have a times 3 here, sorry, plus 308 equals 21. So we see 5 times 7 is 35. 35 plus 308 is 343. cube root of 43 is 7 times 3 is 21. So this is not extraneous. So that's good. But we know that because it's cube root function. Anyways. Okay, sorry about that. There's some, if you hear a background like computer noise, my computer's just like old and messed up. I'm recording on my iPad, but it, that's why it's doing that noise, and I have to have it open right now. Okay, here's a different one. So we know that really, I already told you that this is the same as a cube root, even since, because in this problem we have, it's raised to the 1/3 for both. But I said that you have to isolate the radicals. Well, there's radicals on both sides. Since they're the same, we can multiply by the reciprocal already. And if we did that, we would just get 1. So we can pretty much eliminate that. So now we have this, and that looks a lot better. Okay, so then we would have 5x minus 23 equals 17. And then 5x equals 30. Wait, 30, what? No, 40, sorry. I don't know what I was doing. And x equals 8. So, that's our answer, but is it extraneous? Let's see. I'm just going to pretend like there's an 8 here that I plug in. So we have 7 times 8, so that's 56 minus 23. That is 33. 33 raised to the 1/3 power is 3.2 approximately. Let's see, we have 2 times 8 plus 17. That's also 33, so we already know that the cube root of 33 equals the cube root of 33. So that's not extraneous, so that's good. Well, once again, we already knew that because 1/3. If it has an odd denominator like that, then that, or index, we know that it has to cross the axis at one point. Okay, so... Okay, I can close this computer now. The thing I was doing finished. Okay, so now we have a different problem. It looks a little bit different on this one. So the radical is already isolated, so we don't have to do anything. You know that when there's nothing there, it's really a 2. And if you think about it, this is really raised to the 1/2 power, because we have 1 for the exponent in there, and then we have 2 right here, so 1/2. So that means we need to multiply not by 1/2. That's not what we do. We have to do the reciprocal, so 2/1, or just 2. So we do that on both sides, so then the radical can be eliminated, and so now we just have 54 minus 3x equals x squared. Ooh, that means we might have 2 answers this time. So let's see. Now let's, we need it to equal 0, because if we're finding the zeros, then it needs to equal 0. So we have x squared. Let's just put it in the standard form that we've used before. Okay, equals 0. So now we can factor. So two things that multiply to equal 54 and add to equal 3 are 9 and 6. Since it has to be positive... Oh, wait, that wouldn't work. That wouldn't work, actually, because it has to be positive 54. And it has to be negative 3. So what we can actually do is, instead of, we move the x squared to one side. Oh yeah, that's because we had the negative here, sorry. This has to be 1 for us to be able to factor. So we change this to negative. So this is actually negative 54, and we'll have to remember to divide by a negative 1 later on. See a different video about how to factor in a different unit. So now that it can be negative 54, and it has to be negative 3, negative 9 is what we can do. So x minus 9 times x minus 6 is what our factors are. And since we did this with the bottoms up factoring, we need to divide by negative 1. So now we have x plus 9 and x minus 6. So they just change signs, that's all. And then we would get x minus 9 and, x equals negative 9 and x equals 6. That's our answers. Are they extraneous? Let's see. So if we plug in x here, or negative 9, we get 54 minus, or plus 27 actually. 54 plus 27 is 81. The square root of 81 is 9. And 9 does not equal negative 9 because we would have to plug in negative 9 here. So that actually is extraneous. So negative 9 extraneous. And since this is a square root function, the 6 could be too. Because it could be like this. If it wanted to be like that. So let's plug in 6. 54 minus 18 is 36, which equals 6 on this side and 6 on the other side. So that's not extraneous. So that's the answer. And hopefully this video helped. Thanks for watching, and I'll see you on the next one.